we're going to explore how to calculate the lengths of curves in a plane. We're going to use some mathematics that you've been familiar with for a number of years. The first thing we're going to do is we're going to consider 2 points on a curve. The 2 points I've just circled in red. We're going to do an application of Pythagoras' theorem. What we have are 2 points. And what we want to do is work out the distance between those 2 points. This is just using the same principles as you have done with rise over run. If you had 2 points, x1, y1, and x2, y2, you would have done rise over run by working out how far did it go across. The distance it went across, we called our run. That was x2 minus x1. And how far did we go up? That was the rise. That was y2 minus y1. Now, it's a curve that joins those 2 points. The further those 2 points are away from each other, the greater the inaccuracy in our estimation of the distance between those 2 points. But the closer those 2 points are together, the closer our estimation will be, because our straight line will be very close to the curve. So our x2 minus x1 is going to be a small change in x, which we have called dx. Our rise, our change in y, is going to be a small change in y, which is what we've called dy. Now, using Pythagoras' theorem, d, the distance between the 2 points, is equal to the square root of the dx squared plus the dy squared. So, that is the square root of 1 plus dy squared over dx squared, all times by dx squared. What has happened there is the dx, all squared, has been taken out as a factor. The square root of dx squared is dx, which leaves us in the square root with 1 plus dy all squared over dx all squared, which we have combined to be dy dx all squared. Now that is the distance between those 2 points. So if we were working out a length, so if we were adding multiple little straight lines together, then the length would be the integral from a to b of the square root of 1 plus dy dx all squared dx. And we could write that in a slightly different way. Instead of writing dy dx, f dash x